This field experience presentation talks about the development of a currently traditional structure for a science unit and making it a more purposeful project-based learning unit with the result of a performance task. Project-based learning versus problem-based learning. Project-based learning seeks to engage students in meaningful projects over the course of an extended period of time, where they are answering complex questions, and it is self-designed and facilitated by a teacher. The project-based learning outcome is that of a true, authentic product that is typically presented in a public forum to the outside community. Project-based learning can seek to level the playing field as well as help students become college and career ready. Currently, the practice is 27 teacher-led traditional style lessons. There's one germination inquiry. It is aligned to standards. There are very limited supplies. The science process standards are embedded into the unit. There is a science notebook format and a final performance task where students are expected to create a garden, design a garden. However, this particular format has been in place for about 6 years, and there is a disconnect. When students get to the performance task, they have a really difficult time making the connections between the content and skills that were learned in the unit and then application of those skills to design the garden. So when looking at the elements of a project-based learning unit, I did find that there are definite absolutes that are necessary, but then looking at other ways to incorporate other elements of what's expected in the science unit. So the roots of the PBL design include meeting national standards, next generation standards, as well as nationally aligned K-8 model competencies as outlined in the New Hampshire Department of Ed website. There's also learning targets that are outlined in the unit supplied by the school district, as well as the essential elements of a project-based learning unit, project-based teaching practices that go hand in hand with the elements of PBL, and ongoing formative assessment, as well as ongoing teacher professional development, where teachers really need to facilitate a culture of PBL within the classroom. Teacher and student work along with coworkers and other teachers. All of this comes together in a collaborative nature to design a PBL unit, and then ultimately culminates in a performance assessment that really is truly designed and built along the way. So when it comes to doing the performance assessment at the end of the unit, it is not just an isolated event. Students have been building throughout the whole unit, and it really is a nice finished product from their learning. So the elements of a project-based unit go hand in hand with project-based teaching. Both of these graphics show the essential elements and how no element is more important than the other. The essential product design elements do really establish a structure. It can feel like a project-based learning unit could be a little loosey-goosey, but when the structure is in place, the learning is extremely purposeful and guided by that structure. And the project-based teaching practices also are very structured, very purposeful, and go hand in hand to support the ongoing unit. So in looking at the development of a project-based learning unit, it came to be that it's quite evident that although this takes more time, you could actually get a lot more accomplished in the amount of time that this unit takes. So out of the standards, the next generation science standards, the learning targets, and also the cross-curricular connections, 47 standards are actually met and could be assessed in this unit. So again, the amount of time it takes could be seen as an obstacle, but when you look at how much you can accomplish within the unit over that time, perhaps it is the most bang for your buck. And then beneath all of these standards are the activities and assessments that would be designed to help students reach the standards. So in looking at one of the elements, the learning targets, students are expected to understand the codependency between plants and animals in order for them to survive. So the guiding question is, how can a garden's design support plant and animal survival? And working backwards, the performance task would have students being able to design the garden so it does answer that question. The Next Generation Science Standards, as well as the nationally aligned model competencies, also have that learning target built in. And then, as you can see, it does reach across various content areas. However, math does not have a standard that it would be able to support. Then there's some voice and choice in the activities that could be potentially available to the students. They could do some research on plant and animal codependability, and design a website or blog that could describe what that is. They could create a terrarium where students are observing plant and animal interactions over time. They could also visit a local garden or greenhouse, interview a gardener, design questions with a focus on plant and animal dependability. In the future, it is quite possible that a project-based classroom could really weave all the curricular areas together. A very, very large task that really is a development of culture over time, but definitely something that is doable and would take a lot of development, training, stamina, and that kind of connection that could really learn to some significant, meaningful learning for students and staff.